Hello everyone and welcome back to CodeSploit's exclusive series on mastering Linux. This is part 8 of mastering the Linux basics, and today we are going to take a look at managing processes in Linux. So the command we are going to take a look at is the ps command, which stands for actually the process status, which is used to provide information about the currently running processes, including the processes identification numbers or the PIDs. So let's run ps and let's see what happens. So you can see that it listed out two processes. So as when ps is used without any standard options, it sends just the output, which is the processes running on the foreground actually. For example, we have mainly three switches which we are going to use in our future tutorials. For example, this ps A switch, which lists out the PID, the terminal type, the process status, the time used, and finally the command. So let's understand what all this is. So TTY, or basically come to PD first. PID is the process identification. Every process in Linux has a specific identification ID, which is basically a number. So with that specific number, you can just identify every process separately. Next, we come to TTY. TTY is actually the terminal type, or is the name of the console or the terminal. For example, the console or the terminal means it's a combination of the monitor or the keyboard and that the user is logged into, and which can also be found by using the TTY command. This TTY information is usually important to users on a multi-user network, or basically on a LAN where there are lots of users. But basically if you're running this on a VM, so this doesn't have much significance. Fine, let's come to stat or the status or the process status, which means what is the condition of the process right at this moment. So I'll come to this in our advanced tutorials. For example, S means the process is sleeping, means the process is not running in the background, and capital S and small s has got different values for sleeping. Capital S has got more priority, and I'll come to that later. Fine. Next we come to the time. Time is the period which is passed since this process has started, and finally the command with which is running, or basically the command is if you just copy this right to your terminal right here and you just paste it, so you can just start this process right again. Fine. So let's get to ps uswitch. So ps uswitch tells us all the processes that are being used by the present user. For example, I'm running this as root, so you can understand that all these four processes are on the foreground. Okay, so and let's take a look at PSX. The X option adds to the list of processes that have no controlling terminal. For example, in Linux you refer every process as daemons actually. So the X option adds to the list of processes which have no controlling terminal actually, which are all the daemons, which are the programs that are launched during the booting, that is the computer startup, and run actually obtrusively in the background until they are activated by a particular event or a condition actually. So as I have told you, we can come to piping commands. So what if we do a ps followed by A, U, and X, all three commands together. So if you press an enter, you can see just a long list which is coming up right over here. So let's understand what all these columns right over here are. User stands for the main owner of the process, or the owner's process which is running right over here. PID is the process identification. Index actually, or the process index. As I told you, every process has a unique identification number, which is the PID. The percentage of CPU being consumed by specific process, the percentage of memory being consumed, And let's come to this part. which is VSZ. So what is VSZ? VSZ stands for the virtual memory size, or basically the total memory that the process can actually access, which includes the memory that is swapped out and the memory that is from the shared libraries. And next we come to RSS command. RSS is actually the resident set size, or is the column which is used to show how much of memory that is allocated to a specific process, and it is and this RSS means this process. This number is in kilobytes actually, and let me tell you, it does not include, this RSS does not include the memory that is from the, or that is basically that is swapped out, whereas VSZ includes the memory that is swapped out. And in case of RSS, it does show the memory that is from the shared libraries, and it does include the total of all the stack as well as the heap memory size. Next, as I've told you, is the TTY. TTY is the terminal type. Next is the status, process status, and finally we come to the start, which is the starting time of this process. And next we come to the time, which is the time elapsed since this process has started. And finally we come to the command with which we can initialize all these processes. Fine. And let me tell you, process numbers, or the PIDs, which we are since we are working in Linux, these are critical, and as you often need PIDs to manage a process, so you might have seen I will be using these PIDs in my future tutorials, in my Metasploit maybe. This PID often becomes very critical in hacking the victim systems. We need to kill a specific process to stop the user from knowing that we are on the system and many other stuff. So please be serious with these PIDs and don't mistake one PID for the another. For example, if you are just shooting up a PID, in case of the 37 you put 36 and you're gonna be screwed up, let me tell you. And finally let's come to another command, which is the top command. And similar to the PS command, is the top command is the difference is that the top shows us only the top processes which we are running. In other words, it shows us the processes that the most resources, the processes which are using the most resources, and it's dynamic. For example, let me just type in top, so you can just understand that how much process is being applied. And you can see this is really dynamic, and it will just tell you which process is using the most memory or which process is using the least one. Fine. And next we come to killing processes. Sometimes we will need to stop processes in Linux. Let me tell you, this command, the command you use is the kill. Don't worry, it sounds actually more violent than it actually is. So what is this command? This command is particularly important if we have a process that continues to run and use the system resources even after we try to stop it. And these processes are actually referred to as zombie processes. Maybe if some hacker is in your system and he wants to exploit you, so you need to stop him. So what we do, we take up a simple PID. For example, let me do a PS aux. Okay, fine, UX will do. So let me just search for a simple let me be this, maybe SDPAM, which is sleeping right now. So the process ID is 720. So what we will do, we will just use kill followed by 720. So if you do a PS AUX again, you won't be able to see process 720 right there. You can see it's finished. So this is how you stop particular processes forcefully. Okay, fine. So what if you like to stop multiple processes? So you can do something like this: kill followed by process 1, and then process 2, and then process 3, and finally so on. And one thing, remember, while killing processes, don't mistake these PIDs. And if you stop the run processes, your system may shut down and you may just harm your computer without yourself knowing anything. So this is it for today's tutorial. I'll be looking into more depth on this in my second part. See ya.
You